okay if we start here?
Yeah, sounds good.
All right. So vertical asymptotes. So vertical asymptotes here are where the bottom equals 0. So you're solving that for x. So in this case, you subtract 3 from both sides, so x equals -3. I've talked with both of you about graphing as you go. X equals -3, something like that. To get the horizontal asymptote, which is the next thing it asks for, there's a couple of ways to do it. The way that I've maybe showed both of you is that you can actually look at this number here, the number off to the side, or you can make a common fraction. I think we've done that. So I think this would be a good point to, well, you end up doing that in part D anyway, but let's just do it here. So the horizontal asymptote is y equals -5, and that's a horizontal line through -5, like that. Again, if you guys have any questions, please just either, if you're uncomfortable, just send them through the chat, or just unmute yourself and jump in. Don't feel like you can't do that. That's absolutely what we want here. So to to do part C here is domain and range, and that's based on the horizontal and vertical asymptote. So the domain is -infinity to the vertical asymptote, union vertical asymptote to infinity. So if you guys could take a moment and try to work that out, based on what we did here in this problem.
Wait, sorry. So what does the VA, vertical asymptote?
VA is what I use for the vertical asymptote.
Okay.
X equals -3. That's the separator, and that's the number that you're going to use in there.
All right, thank you.
Claire, do you have any questions on that?
No, it makes sense.
Okay, so if one of you, maybe Claire, since you're there, if you could give me the domain here, I'd appreciate it.
I don't know if my teacher does it differently, but we say as x approaches negative infinity, y cannot or like y equals -3.
Yeah, so you're talking about end behavior, and we'll get to that. We'll get to that. Is that maybe you guys are using set notation?
I
I'm not
think
really
so.
sure. So this is set notation x such that x is an element. Is that what you're talking about?
Yeah, that looks more familiar.
Okay. All right. Sorry, guys. I mixed this up because some people use one or the other. So this is saying x cannot be -3. That's the domain. So it's an exclusion. So that value is being excluded.
So for the range, are you using the horizontal asymptote?
Exactly. Y element real numbers, y cannot be whatever that number is.
So for these problems, it's like the vertical asymptote is always the x plus blank or x minus blank equals 0. For the horizontal asymptote, it's always the number that's by itself at the end.
Yeah. Now when we rewrite it into a common fraction, it'll be a little bit different. That is the general way to do it. Yeah.
Okay.
Claire, any questions on that?
No, it's good.
Okay. All right. I may mess up and use interval notation again, so just remind me that you guys are doing set notation if I mess up. Part D, this is the big one. This is the one where I'm pretty sure we both of us have worked on this. To make it a common denominator, you have to treat this 5 as 5 over 1, and then you have to multiply the top and the bottom by x plus 3. So what I'd like each of you to do is to try to do this on your own and let me know when you're done, and then I'll work this out as well for you guys. The goal is to get it as something over x plus 3.
Um, Do you want me just to say the answer that I got?
Nope, just hang on, hang tight.
Okay.
We'll see if Claire's got any questions.
I also have the answer.
Okay, so yeah, then we'll do this a little bit more like the teacher approach here where I just work it out. It's 3 minus 5x minus 15 on top, combine like terms, minus 5x minus 12. If you have something different, that's fine. Just look and see where your mistake is or differences. Any questions on that?
No, I'm all good.
I'm good
Claire?
too.
Okay, great. So the reason you do all this is that you can also find the horizontal asymptote by looking at the degree and the leading coefficients. So the horizontal asymptote is y equals the ratio of the leading coefficients, which is minus 5 over 1, like that. The other things we can find here are like the x-intercepts. Do either of you remember how to find the x-intercept when it's in this form?
Do you just do the same thing as like the vertical asymptote?
You set the top equal to 0. Top equal to 0.
Not the bottom?
The bottom we've already dealt with, so the bottom is where the vertical asymptote is. The x-intercept is where it
Oh.
crosses the x-axis.
Is the y-intercept where you make all the x's become a 0?
Yes.
Okay, I think that's where I got confused.
So I'd like each of you to find the x-intercept. And why don't you put your answers in the chat? You can send them directly to me or to everyone.
Wait, sorry, did you say for the x-intercept?
Yeah, why don't you guys put the x-intercept, whatever you find for the x-intercept in the chat. Decimal or fraction is fine. All right. So is the answer positive or negative, Zach?
I was initially thinking positive because you bring the 12 over, and then
Okay,
if
but
you divide it by
negative
negative 5,
five
and
then.
now so it stays as negative 5, correct?
Right. So you end up getting negative 5x equals 12 divided by negative 5.
Divided by
X
negative
equals
5. Alright,
negative
I don't know, I
12 over
was thinking
5.
I had to make it positive.
Or as Claire put it, or what she wrote the fraction, it's okay to do the decimal. Claire, your other answer is correct. Could you talk me through how you did that, Claire, for the y-intercept?
Yeah, I plugged in 0 for all the x's.
Okay. And then how did you simplify this?
And then I got to negative 12 over 3. And
Okay.
then that would simplify to 4, negative 4.
Very good. Okay. Zach, you have that down in your notes that you want to put 0 in for x to find the y-intercept?
Yeah, I wrote that down.
All right, very good. Now we really should be graphing as we go. Okay, and we kind of were. I mean, we have the x vertical asymptote at x equals minus 3, y equals minus 5. Now we can add in some other stuff. The y-intercept and then the x-intercept. Now, I think your teacher also had you do some things like where you evaluated the function at extreme values. Did you guys have any problems like that where you had to find like g of 100 or g of minus 100?
Yeah, I had a couple like that.
Okay. Zach, did you have anything like that?
Would that be like in a table format? Or
Could
I'm
be.
not sure if I
It could be.
recognize that.
They're just trying to get you to be able to answer the how to graph this thing.
Would it be like a lot of different numbers and you just fill in like 1 or 2 of them?
Well, I didn't really like this when I saw it from the other students, but they're trying to get you to see if there's a point here point way out here. I'm just trying to connect them. Any questions on this so far?
No, but I think I really kind of want to work on like finding more points like to plot because my teacher wants like 3+ points.
Okay, we can do that for sure. Maybe that's your time about with the table, Zach. Let's see. But any questions on this example?
I guess for like the actual lines of the graph, I have a question. Like I had a quiz, I think like last week on this,
Okay.
and we had like these graphs, we draw it in, and then when we make those lines, like I didn't know exactly where to make the curve of the line. Is
So,
that just like given?
Yeah, so you can't cross the horizontal or the vertical.
Yeah.
That's one starting point. So you connect these, but where do you go from there? But it has to approach one of the asymptotes.
So like,
So
or I
so that,
guess
so
it's
that
like a matter of like I understand that they have to be like reflecting in a sense,
well,
but
yeah, but that's where making the table comes in handy. So let's actually do that a little bit with this one. So I think it's a good question. Excuse me. Okay, so you want to pick values in each sort of region of the graph, like left of -3, like for example, -5. So Claire, would you evaluate this function at -5, please?
yeah, one.
are you just inserting the -5 into the x coordinates?
Exactly.
Okay.
-5 times -5 minus 12, negative
Uh,
5 plus 3.
I I got -13/2.
Okay, so this is another place ordered pair that you can graph on there. Like you need a point and you find, okay, it's down here maybe. And that helps you to figure out where to graph it. Um, you could go like a -4. You want to try that for us, please?
I got -8.
Yeah, I did as well.
Okay, so that's another point you guys can graph on these, -4, -8. And then you want to go to the other region somewhere to the right of the vertical asymptote. So you've already done like a couple of these, but why not do like +2, maybe?
So that would be like -22/5.
Okay. Do you agree, Claire, with that?
Yes.
Okay. So I think you're getting the idea here. You can make a table. So, I just connected them, but you guys probably need to make the table. So we'll do that in the next example. Any questions though on, vertical asymptotes, horizontal asymptotes, domain range, rewriting, x-intercepts, y-intercepts, any of this that we did just now?
I think I'm good.
Claire, do you have any
Good too.
questions? Claire, do you have any questions you specifically want us to do? If so, please send them over by text or email.
I don't have any specific ones.
That's fine. I'll come up with an example here. Okay. So we're gonna divide and conquer here a little bit. Zach, I'm gonna have you find the vertical asymptote, the domain, and the x-intercept. Claire, I'd like you to find the horizontal asymptote, the range, and the y-intercept. You will both need to make a common fraction at some point. But this is a time to ask questions. Hey, I don't understand, or I do understand. Please ask some questions if you're not sure how to proceed.
I guess I have a question with the x-intercept in this one.
Okay.
So I'm using the bottom and I'm just
Nope.
making it x
You
minus
got to
1
make
equals 0.
to do this part. You really need to make a common fraction. You really need to make a common fraction to do the x-intercept and the
Oh,
y-intercept.
my bad. So that's where I put x minus 1 into both areas.
Yes.
Okay.
Okay, so for the horizontal asymptote, I got y equals -3.
Okay.
For the range, y such that y, e, r, and then x cannot equal -3.
Well, why this time? Because it's the range.
Okay.
Good. Okay. And do you have your common fraction, Claire?
Yes, it
Okay.
was
Hold off on that. Yep. If you feel comfortable, you can do the y-intercept as well.
okay. Y-intercept was -5.
Okay.
For vertical asymptote, I got +1.
It's an equation though. So what is the full equation?
Oh, I got x minus 1 equals 0. And
That's right.
then
But when you solve it for x, it's a full equation. It's x equals
x equals
what?
1.
Yeah. It's like the horizontal asymptote is y equals -3.
Because it's going left and right, and then
Yeah.
verticals up and down.
So your
And then
domain x
I got x cannot be greater than or equal to 1.
just cannot be 1. Can't divide by 1.
And then the x-intercept, I'm not positive if I did this right, but I believe it's um x minus 1 equals 0, and then that's x equals +1.
The vertical asymptote and x-intercept can't be the same. So remember, you got to make a common fraction. So let's do that now.
So
Let's make a common fraction. Claire, what do you multiply the top and the bottom by on the right?
X minus 1.
Good. Zach, you cannot find the x-intercept or the y-intercept until you make a common fraction. That's the best way to go about doing it.
yeah, so like I did that and I got to like -3x plus 5 over x minus 1.
Okay, that's good. Um, Now you set the top equal to 0. Claire, is this the fraction you got?
Yes.
Okay, you set the top equal to 0 for the x-intercept. What does that become when you solve for
That
x,
would
Zach?
be 5 over -3.
Try again.
Uh, x equals 5 over -3.
So you're subtracting 5. Negative 3x equals negative 5. You're dividing by negative 3. So x
Divide by
equals
5
5
here.
over 3. Okay, now we should have been graphing as we go. So the quick sketch of this is x equals 1, y equals minus 3. Okay, and then we can do the x-intercept and the y-intercept. For the y-intercept, 0, negative 5 is down here. The x-intercept is 5/3. This is where you would make a table. Let me go back and grab the function here. It might be worth making a table here. So x and y. You'd want to pick a value to the left of this, like maybe at -1. Claire, will you evaluate that at -1 for us, please?
Yeah.
And then Zach, why don't you do it at 2? I'm putting 2 in for x.
For 2, I got -1.
Claire, do you have an answer for this one?
Sorry, it glitched. -4.
Okay, very good. So that's here. Now, do you feel like you have enough points? And if you're not sure, you just got to do a few more. You might do like -2, or you might do +3 until you get enough points. But that's up to you. Do you guys want to do more points? Or do you feel like you have enough?
I feel like I have enough, but I'm done for
Claire,
anything.
you brought this up, so why do you feel like you need more points? Like what is preventing you from drawing the curve in here?
Well, my teacher just expects us to have 3 or 4.
Okay, well that's a different issue. Okay. Thou shalt have 3 or 4 points, then thou shalt have 3 or 4 points. So you just sort of slide, one direction or the other.
Yeah, I understand now.
Okay, perfect. Zach, you usually have good stuff to send over. Do you have another paper that you can send over, like this one?
Yeah, so my teacher gave us some, like, study guide of some sort, and
Okay.
could you check that first email I sent you? Because I sent a screenshot
It just none
of
of the
the
equations
document.
came through.
None of the equations came through?
Yeah, the same issue as last week.
Interesting. So, I can try and the school's, accounts are weird, like, I can't log in
Yeah,
to
I
my
know.
email to take pictures of it, so I'm gonna have to leave the meet for, like, a minute or 2 to get
Fine.
pictures of it to send over.
That would be appreciated.
Okay, I'll be back in, like, a minute or 2.
Okay, sounds good. Claire, was there anything else that you wanted to work on specifically today?
I don't think so, and my teacher
Okay.
doesn't assign us, like, homework or anything, so I don't have, like, problems.
Does this look at all like stuff you've been seeing though, like the paper he had?
Yeah, that's, like, kind of exactly what we've been working on.
Okay, great. And I do apologize again for this. It's rare that this was happen, but kind of worked out. What I'm hoping Zach's going to do is send over another problem set for us to work on, so I can make up some more problems like it. You were talking a little bit earlier about end behavior. So if the graphs, like let's say here's one of the graphs again. I could ask you as x goes to infinity, as x goes to negative infinity, what f of x goes to. This
Yeah,
is the end
so
behavior. So this is always towards the horizontal asymptote.
oh, okay. So it would be
Let's say it's y equals 3 here.
Okay, so then would it be as x approaches positive infinity, y approaches 3?
Yes, in both cases. Great. It always approaches the same value. That's another kind of important thing. So you wouldn't get a situation where it approached two different values, but if it was like this, actually let me flip quadrants here. It could be like this and like this. This is y equals -2 as x goes to infinity, as x goes to negative infinity, f of x goes to,
F
it
of
would
x
be,
goes to -2?
yeah. All right, Zach's coming back into the meeting, and he was able to, yeah, this is good.
Could we go back to the last graph really quickly so I can write it down?
Here, this one up here, or
Yeah,
something
thank
different.
you.
Okay. Hey, Zach, thanks for sending that over. We'll work on that problem type next.
All right, thank you. I have a question with what I sent over. So
Yep.
I know the test is going to be on polynomial and rational functions, and like with it, you have to say the graph, the zeros, and the asymptotes. Is question number 1 polynomial or rational?
Polynomial.
Polynomial. Okay, thank you.
Yeah. The ones we've been doing are rational. If you see division, that's rational. Now, have you worked
Okay,
through
I
this
got it,
problem?
thank you.
Yeah. Zach, have you worked through this problem yet?
No, the ones I sent you I've saved
Okay.
for this
Claire,
meeting.
Claire, have you seen this before, this problem here?
Yes, I think so, yeah.
Have you worked through it? I'm asking to know whether we can work through it or I need to make a different one up.
We can work through it.
Okay. So the first thing is you're always going to use synthetic division unless you really can't because it's easier, it's better. So what number goes in the box is x minus 1 equals 0. And you're solving for x. You're adding 1 to both sides, so x equals 1. That's what goes in the box there. 1, -2, -5, and 6. Is that okay?
So, are we using 1 because it goes in all these problems, or
1x cubed. Well, there's a 1 in front of the x cubed. You mean the one in the box or
Oh,
the
oh,
one?
my bad. So I forgot. So you're looking at the first, or no, no, not the first. Are you looking at the largest, like cube squared number,
Not
and then
yet.
we use the number in front of it?
Well, you start with the leading coefficients in descending order.
Uh-huh. So it's already in order from
Yeah,
largest to smallest.
yeah.
Okay.
All right. So we're gonna bring these down 1, and then you take the 1 here, multiply it by 1, that's 1. It's -1. 1 times -1 is -1. Add, it's -6. -6 times the 1 is -6. You should get 0 there if it's a factor. You should get 0 there.
Should you always get 0?
If it's a factor. If it's a factor, then yes.
Okay.
All right. So Claire, can you tell me what the new polynomial is? It's okay if you don't know. I'm just asking.
Would it be x squared minus 6x?
It's -1x
Okay,
-6.
yeah, I forgot about that, okay.
It's okay. So it was x cubed, it was x squared, was a constant, and now it's this. Okay. So you're trying to factor this, two numbers that multiply to -6 but add to -1, multiply to -6 but add to -1.
Like -3 and +2.
Yes. So this is called factored form. Factored form gives you the x-intercept. You get the x-intercepts by setting each of the factors equal to 0. Zach, could you give me the x-intercepts there, please?
X equals +3, x equals -2, and x equals +1.
Good. All right. Claire, any questions on that? What we did there?
No, I'm good.
Okay. The next thing is to find the y-intercept. It is better to go back to the original form. The y-intercept is just like before, you're putting 0 in for x. That's 0 to the power of 3 minus 2 times 0 squared minus 5 times 0 plus 6. What does that become?
+6.
Positive 6. So as an ordered pair, it would be 0, comma 6. Zach, any questions on how to do that?
So there's one y-intercept and there's 3 x-intercepts, and those are the points that are going to be on our graph.
Yep, you're way ahead of me. We need to be graphing now. We need to go and
Oh, wow.
graph those points. 0, 6. Okay, and then we need to graph the 3, -2, and 1. And then now we need to figure out end behavior. So you do that by what you were alluding to earlier, which is the degree and leading coefficient. It's usually easiest to go back to the original to figure that out. Claire, do you remember what the degree is here?
Would it be 6 because you add the degrees?
It's the highest degree power.
Oh, right. So it'd be 3.
This one's odd. That's important. Zach, do you know what the leading coefficient is?
Would it be 1?
It is 1, which is positive.
So, my question, so are you saying so is odd just because it's a 3?
Yes.
And then +1, or like, I don't think I've ever seen the odd and positive thing before, like, what
We actually
exactly
don't
does that
care
mean?
what the number is. You care whether it's odd or whether the leading coefficient is positive or negative. Because
Uh-huh.
there are 4 graphs that you need to know.
Oh, okay, wait, now I get it for positive or negative, because it's like whether
Yeah.
or not it's an actual negative number or not.
So there, I've drawn 4 arrows, A, B, C, and D. Do you have in your notes, Claire, which ones we should use for when it's odd degree and positive leading coefficient?
It's either up and down or down and up, but because it's positive in the front, would it be up and down?
Give me the letters to keep, A, B, C, or D. Which one should I keep?
So A and D.
That would be if it was negative. So we're gonna end up
Like
keeping
B and C.
B and D, B and C. So you gotta, it's your responsibility to know those graphs. Like I can only tell you the information.
Do you think you could make like a little not like drawing, but just like an ex or like just like showing each one like with which one's negative, positive, negative, negative?
Yeah, there's 4 graphs. Even. A is leading coefficient, positive, negative, positive, negative, odd, odd. So high and high, low and low, low and high, high and low. Any questions on that, Claire?
No.
Do you have a way that you remember this, or do you just write them out?
I'm just gonna write it down.
Okay. All right. Now, I did have another student come to me with a problem like this one that I'm about to put in front of you. Is it okay if I move past this?
Yeah.
Yes.
Okay. So f of x equals, and it was like x to the fourth minus 5 x squared minus 4. And this is a higher order factoring problem. If this were u squared minus 5u minus 4, how would you factor it?
Uh, wait, sorry. So that's like the once you already pull the main number and like
Yeah,
do the
once.
synthetic division.
No, I'm trying to give you something totally different that I think could be on your test quiz because I've seen it from another student. And you
Uh-huh.
haven't seen it yet. It's a higher order factoring problem. Claire, do you have any idea what I'm talking about here?
Do we find like the not two numbers that multiply to +4 and add to -5?
Exactly, yeah. That's u minus
So like
4.
-1 -4. I mean -1 -4.
Right, so this becomes x squared minus 4, x squared minus 1. And the reason this is useful is it's difference of squares. Do you know what that becomes?
Which part are we? So we're writing those numbers, then -4 and -1 in the other
Yeah,
two.
those break apart in x minus 2x plus 2. And then this x squared minus 1 becomes x minus 1, x plus 1.
Okay.
And just like the problem we did, it's breaking this down into factored form.
So then, those are all just going to be the x-intercepts, correct?
Yeah. Yes. So the x-intercepts here are 2, -2, 1, and -1. Claire, could you tell me the y-intercept? Maybe going back to the original form here.
Sorry, +4.
Yes, 0, 4. Good job. You can graph these. -2, -1, 1 and 2, 0, 4. But you still need to know the degree and the leading coefficient. So we go back to the original problem I gave you. Here it
The
is.
leading coefficient would be 1,
Yes,
and the degree would be
positive,
4.
which is even, yeah. So it's the same question I asked you, which of these arrows are we going to use? A, B, C, or D? Zach, could you tell us which ones we're going to use based on even degree, positive leading
I
coefficient?
didn't get those notes fully done, but it might be A to D.
Now let's go take a look.
Would it be the third one?
Claire, do you agree?
I'm not
Is it
sure.
the third one? Was the degree even or odd, guys?
Even.
So it's got to be one of the first two. Is leading coefficient positive or negative?
It'd be positive, so it'd be the first one, up and up.
Yeah, first one. Yeah, so Zach, so take another look at that. DCI came up with the first one.
Yeah.
Breathe even, positive leading coefficient.
So even and positive. Is it alright if I just take a picture real quick? If you scroll back up just to the 4 so I can write that down when we go over the next stuff. Alright, thank you.
Okay, so this is where our arrows are. We know to connect them like that. I did that. All right, it seemed to. Oh boy, it's always something. Put something in the chat here. Yeah, sounds good. So something like this. All right, guys. So any final questions or concerns about stuff we did today? I'm happy to answer some questions. Um, maybe we can go a little longer if we need to.
I think I'm good.
Okay. Claire,
Yeah, I
thank you
think
again
I'm
for
as well.
Zach. If you want to hang on, but Claire, if you want to jump off, I'd appreciate it. I will see you on Sunday at our usual time.
Okay,
And
thank
Zach,
you.
you're welcome. Zach, hold on. Yeah, let me. Yeah, he's out. What's going on, Zach?
Um, Nothing much. So I have my final, I believe, on this Thursday. No, next
Okay.
in exactly like a week, pretty much.
Yep. Yep.
And I was looking at your website, and it seems like you're pretty booked up until Monday, right?
Yeah. So I got on Sunday. I got maybe a 9. Monday. Do you get an early release on Monday or
Unfortunately, no. On Wednesday,
Tu
I'll be
Tuesday?
getting out.
Tuesday. I got 6 and 8. Wednesday. I got 5, and that's it. Well,
What were the Tuesday options?
6 and 8.
Do you think we could try and shoot for Tuesday at 6?
Yep. I'll schedule it right now.
Okay, cool. Thank you.
That way it's all
Um,
set. Yeah.
yeah, I
Anything else?
guess I'll just have my final and I'll try and bring some sources to it, but I'm not sure if I might need another lesson on that or not. So I guess once my teacher gives me the study guide for the finals, which is kind of late,
I think I know.
maybe I'll have to text you and just see if there's any other spots available.
Yeah. I mean, the sooner the better. That Wednesday at 5 is pretty popular, so you might want to grab that, or just tell me. We'll grab it for you.
You know what? Can you just spare me like 1 minute real quick so I can check my schedule?
Sure. Yeah.
Okay, thank you. I'm just trying to pull up my class schedule for what days I have which final because I'm pretty sure it's on Thursday, but I just
Yeah.
want to be very certain. I'm just going through the school slideshow that they announced. Um, you know what? I'll text you in like a minute or two just so I don't keep you waiting.
It's okay. No, you can. If you want to tell me now, it's fine. Um,
Okay, you're all.
take your time.
Um, just okay. Period 4. So yeah, I do have it on Thursday for my period 4 exam, which would be my math. So I guess I would enjoy having the 5 o'clock on Wednesday as well.
Okay. You got it.
All right, thank you.
Let me get that scheduled here before you run off.
All right, and just so I can have it down on my schedule,
Tuesday at 6, Wednesday at 5.
Tuesday at 6, Wednesday at 5. All right.
All right. Thanks again for being accommodating. I'll see you next week.
All right. Thank you, Matthew.
All right. Bye.